Hi everyone, my name is Brandon, and today I'll be showing you some memorization techniques for the unit circle. Now when you reach a math level of Algebra 2 or higher, it will most likely be required that you learn how to fill this out within a certain amount of time. Now today I won't be going into why this unit circle exists and why we use it, but instead I'll be going mainly over memorizing the content. So first we need to know the quadrants, which is just a fancy way of saying the quarters of the circle. So this is quadrant 1, this whole thing. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, now let's get started with the outer coordinates. In the interest of time, I filled out the base coordinates for each spot. Now the most important thing to remember about these is that they are all the same. What is different, however, is whether they are positive or negative. So first we need to memorize these 3 points. We've got 1/2 and the square root of 3 over 2. We've got the square root of 2 over 2 and the square root of 2 over 2. And then we've got the square root of 3 over 2 and 1/2. So these points essentially never change in the sense that this point is always closest to the vertical equator or the y-axis. This set of points is always closest to the horizontal equator or the x-axis. So you can see in all quadrants this is true. So we've got square root of 3 over 2 and 1/2. That's closest to the x-axis. It's the same for here, same for here, same for here. And for 1/2 and the square root of 3 over 2, they're all closer to the y-axis. So closest to the y-axis, closest to the y-axis, closest to the y-axis, and closest to the y-axis. And then we have the square root of 2 over 2 and the square root of 2 over 2, which is pretty self-explanatory. They're always just sandwiched in between these 2 points. So that's not too much to worry about. What we do have to worry about, however, is the signs that we assign to them. So signs being whether these points are positive or negative depending on the quadrant. So I have a simple sign formula to go along with these points. So in quadrant 1, we're going to be doing plus x and plus y. That means positive x and positive y. We can see that's already true by default. And then for quadrant 2, we're going to be doing minus x and plus y. So that means negative x and positive y. So on all of our x coordinates, we're going to put a negative sign. And then here, quadrant 3, we have negative x and negative y. So we have to assign a negative sign to everything in this quadrant. And then for quadrant 4, well, you probably guessed it already, that would be plus x and minus y. So we assign negative sign to all of our y coordinates. Okay, so once you have this formula down and you have your points memorized, you're good. Except you're good for all of these outer points. And then on your x-axis and y-axis, we have 1, 0, 0, negative 1, negative 1, 0, and 0, 1. That's typically, usually, fairly easy to memorize since it's nothing erratic such as square roots or something over something. Okay, now let's move on to the radians. The radians are a little bit harder to memorize in the sense that they aren't particularly the same. I'll go ahead and label the radians in the first quadrant. These are your base radians, and the numbers on the bottom will never change. So here we have pi over 3, we have pi over 4, and we have pi over 6. So like the set of points, whatever is closest to the y-axis in this quadrant will be the closest to the y-axis in other quadrants. Only difference is we use denominators to tell us what is closest to what. So I can label this, label all of the other quadrants with this denominator in pi. So I would go pi over 3, pi over 4, pi over 6, and then I would go pi over 6, pi over 4, and pi over 3. And over here, I do the exact same thing, pi over 3, pi over 4, and pi over 6. Now, these are all of our base pairs, but what does change is the numerators. So, like I said, this is our base pair, and then once you go to the second quadrant, all you have to do is take 1 away from the denominator and add it up here. So if I were to take 1 away from 3, it would be 2. So I would do 2 up here. So that makes 2 pi over 3. And up here, 4 minus 1, that's 3. That's 3 pi over 4. 6 minus 1, that is 5 pi over 6. And in quadrant 3, all I have to do is add 1 to my denominator and put it as the numerator. So this would be 7, this would be 5, and this would be 4. Now this quadrant is a little bit more tricky because the rule is, it's a little bit harder to memorize. What you're going to do is you're going to multiply your denominator by 2 and take away 1. So if I were to multiply 3 by 2, that would make 6, and I would take 1 away, and that makes 5. So if I do that for everything, it goes to 7 and 11. So we've got 5, 7, and 11. And then up here, we've got 0 and 2 pi. We've got pi over 2. We've got pi. And we've got 3 pi over 2. This should be over here. Okay, so if you look at these, you've got 0, you've got like half a pi, so that's pretty easy to remember. It just goes up by essentially half a pi each time you get to a new quarter of the circle. So you've got pi over 2, pi, 3 pi over 2, and 2 pi. So the last thing that we have to go over is the degrees. Now this follows an extremely easy pattern and is perhaps the easiest of all to memorize. So we start in quadrant 1 with 0 degrees, and then we add 30. So we have 30 degrees here. And after this, we add 15 degrees, which makes 45 degrees. And after this, we add another 15, so that's 60. And then we add another 30, and that's 90. And you repeat this for each and every quadrant until you reach a full revolution, which is 360. Okay, so that is our whole unit circle. Now remember, on these, on these two sectors, you're only adding 15 degrees instead of 30. You add 30 whenever you're going to the little outer points of your quadrant. So these are only 15. These are only 15, and these are only 15. Okay, so essentially that concludes this unit circle video. I hope you don't have too much trouble memorizing this, and I hope this helped. Thank you for watching.